Today we will build an end-to-end LLM project that covers a real-life industry use case of equity research analysis. We will build a news research tool where you can give a bunch of news article URLs, and then when you ask a question, it will retrieve the answer based on those news articles. In terms of technology, we have used Langchain, OpenAI and Streamlit. To make this project more interesting, we have added some fun storytelling as well. So let's take a look at that story first.
What if Rocky Bhai lived in the ChatGPT era? How would he invest all his money? Would he use ChatGPT to find best investments? No way. He would hire someone for that. Rocky Bhai's recruitment team got Peter Pandey, the equity research analyst. Peter read lengthy stock market articles for his research, but Rocky Bhai did not like it. Rocky Bhai said,
इस पेड़ से तो कभी काम नहीं होगा.
Peter promised to create a chatbot like ChatGPT for his investment. Rocky Bhai liked Peter's grit and he said,
Fasten your seatbelt.
So get ready folks, we are going to create a chatbot for Rocky Bhai. Perhaps the Rocky Boat.
Equity research analysts such as Peter Pandey in our Rocky Bhai story do exist in real life. Let me give an example of a mutual fund. You might know about all these mutual funds where you can invest your money. So all these three yellow color people are the common people like us who are investing their money in the mutual fund. And mutual fund will eventually invest in individual stocks. Now they need to pick right amount of stocks for which they might have a team of research analysts. And the job of this team is to provide a research on these companies. Let's say Tata Motors, Reliance, how these companies are doing, or what are going to be their profits next year, how is their management, is this a good stock to buy? They do all this research. And in this research team, every individual person might have a couple of stock. Let's say Peter Pandey is working for HDFC Mutual Fund. He might be looking at Tata Motors and Reliance, and his job is to do research on these stocks. Okay, so daily he comes to his job and he will read a bunch of articles from Money Control, Economic Times, or maybe he has access to premium products such as Bloomberg Terminal, and he will do all his research based on the news articles, the earning report, the quarterly financial reports, and so on. Now you can understand reading news articles from these various websites is tedious task. There are so many articles, so much information to consume. See here I'm showing a P&L of Tata Motors. Why don't we build a tool which looks like this, where you can put bunch of news article on left hand side. I'm showing just 3, you can have n number of articles. And then when you ask a question, okay, so see I'm showing all these articles and these are like different articles on moneycontrol.com, and when you post this question, it will retrieve the answer 6.55 to 8.1 lakh. That was the answer. And it pulled that from this particular article, see? And the article link is in the below, okay? And you can also say, okay, give me a summary. I mean, it doesn't have to be the number. The answer doesn't have to be only one number. It can also summarize the entire article, okay? I know about all this because when I was working with Bloomberg for 12 years, in Bloomberg Terminal, we used to get research reports from Jefferies, Oppenheimer, all these different companies, and we would process that data and show that data on the terminal. Alright, so I hope you have some understanding of the industry use case. This is a real industry use case. This tool can be used by companies such as Jefferies, Oppenheimer, alright folks? So this is not some toy project. Let's think about technical architecture now. We need to go back to basics in order to build the technical architecture. Whenever you talk about building any LLM app, the first thing that comes to your mind is, can I use ChatGPT for this? Because ChatGPT is free. Well, actually you can. You type your question in ChatGPT and you say, answer this question based on below article. Do not make things up. And then from that news website, you copy paste the article here. And what happens is, ChatGPT has a capability, see EPS is 8.35. It can pull the answer from that given text. So the question is then, why do I need to build this tool? Why can't I use ChatGPT for this purpose? Apparently there are 3 issues with this approach. Number 1 is copy pasting articles is tedious. Equity research analysts are busy folks. They don't have time to go to website, copy paste, and then get the answer. They also need an aggregate knowledge base, because when they're asking questions, they don't know where the answer might be. They might have this question: how many let's say Tata Nano, Tata Motors sold in last quarter? Now the answer might be in any article. So how do they know which article to pull? And also some answers might be spread over 3 or 4 different articles. Okay, so they need some kind of aggregate knowledge base, and ChatGPT can't give that. And third issue is ChatGPT's word limit. In ChatGPT, you can't copy paste a huge article. It has a limit on number of words you can supply. So we need to build some kind of tool where it can go to the news website, which our equity research analyst is putting trust on, and it pulls all those articles into some kind of knowledge base. So here the database that I'm showing here is some kind of knowledge base, and you can build a ChatGPT like chatbot which can pull data from that knowledge base. Now let's think about this particular article on NVIDIA. Let's say I have this particular question, okay? What was NVIDIA's operating margin compared to other companies in semiconductor industry? And give me the answer based on following article. And when I give that entire article, it will give me the answer in a perfectly fine expected manner. But let's think about it. We are building a tool here. We are not using ChatGPT. So obviously behind the scene, we will be calling OpenAI API. And whenever you call a OpenAI API, there is a cost associated with it per 1,000 tokens, or if you want to think about tokens in a simple layman language, you can say, okay, word maybe. Okay. So amount of text that you supply to OpenAI, there will be cost associated with it. So if you supply more text, there is more cost. But read the question carefully, folks. This is very interesting. The answer of this question is actually in the first paragraph. We don't have to supply second paragraph. It is not necessary, because see, 17.37%, that's the answer. And therefore you don't need to supply the second paragraph. So is there a way we can smartly figure out that, okay, for this question, I need to only give this much chunk? If you do that, you will save a lot of money on your OpenAI bill. Okay. So just think about this article as 2 different paragraphs, and based on the question, you can figure out which paragraph to supply in your prompt. Thinking about this in a generic way, you might have a bunch of articles, let's say on NVIDIA, and when you are asking a question, what's the price of H100 GPU? You want to figure out a relevant chunk. So let's say the relevant chunks where H100 GPU price is mentioned are chunk 4 and chunk 2. In this case, when you are building your prompt, you don't need to give all the chunks 1 to n into your prompt. You can just give chunk 2 and chunk 4. Chunk is just a block of text which is relevant, where the answer might be present for your given question. Okay. And when you do that, it will give you the fine answer. So the question now comes is, how do I find relevant chunks? You can't use direct keyword search. I can't say, okay, H100 GPU. It's like Control F. Try to look into all the chunks, and wherever H100 GPU is present, give me those chunks. Okay, H100 GPU is probably a simple example, but look at this example. When I go to Google and say calories in Apple versus revenue of Apple, it knows that the first one is a fruit and the second one is a company. How does it know that? Well, it uses a concept of semantic search. It looks at the context. We as a human, when I say calorie, I kind of figure out it's a fruit, and revenue is of Apple is company. Similarly, in any NLP application, if you're using semantic search, it can figure out based on the context, what is the meaning of this word Apple? Is it a fruit or is it a company? And we use something called word embedding or sentence embedding and a vector database for this. I have given a separate video for this, so because this explanation might take more time, so I don't want to spend time explaining all these concepts. If you know this already, then fine, you can move ahead. Otherwise, the link of this video is in description below, so you can pause the video and watch that one first. But let's say, just for simplicity, embeddings and vector databases allow you to figure out. So embeddings will allow you to figure out a relevant chunk, and vector databases will allow you to kind of perform a faster search on that database, and then you can give your prompt to OpenAI and get the answer. So now thinking about the technical architecture, the first component will be some kind of document loader where you can get all your news articles and load it into that object. And then the second one will be splitting that into multiple chunks and then storing that into a vector database, so that when you have a given question, let's say I have a given question, what is the price of H100 GPU? You can go to vector database and retrieve relevant chunk, which is chunk 2 and chunk 4. Okay, so vector database allows you to perform that faster search, because this vector database might have millions and millions of records. Okay, so the way vector databases are designed, they help you do a faster search. And once you have that question, you give it to your prompt and you get your answer. In terms of Langchain, we will be using all these classes that I have shown in the orange color, and we will be building our application. Now, for a short-term phase 1, we are building this particular tool in Streamlit. When you are doing this project in the industry, let's say you are working as a data scientist for Jefferies, you're not going to build the whole project in one go. You will first build POC, proof of concept, where you will build this kind of tool in Streamlit. You know, left side, number of article URLs, and the right side, you put a question, gives the answer. So that way you get a confidence that this approach works. And once we are happy with the result of this tool, for long term, the architecture may look something like this. You need to first build a database ingestion system. It will have two different systems. First one is a database ingestion system, where you go to your trustworthy news article website, you write a web scraper, and you have it implemented either in native Python or tool like Bright Data. And then you run that on some kind of cron job schedule. Let's say this cron job runs every 2 hours or every 1 hour. It will pull the data and it will convert that text into embedding vectors using OpenAI or Llama or BERT, whatever embedding you want to use. Then that goes into vector database, and for vector database we can use Pinecode, Milvus, Chroma. These are like popular ones today. We can use any of these solutions, and that will be your database ingestion system. The second component will be chatbot, where in React or some kind of UI framework you will build chatbot similar to ChatGPT. A person types in a question gets converted into embedding. Once again, OpenAI or Llama, whatever embedding you want to use. And then from vector database, you pull relevant chunks. So this green and orange are relevant chunks, which matches with the question, what was Q3 2023 EPS for Tata Motors? And then based on those chunks, you form your prompt, you give it to a LLM, and the answer, you put it back into your UI for the chatbot. So again, this is the overall architecture that you will be working with. Remember that when you're working in industry as an NLP engineer or a data scientist, you first do brainstorming with your team, you come up with this kind of nice technical architecture, and then you start doing some coding. Okay, you don't want to go into a wrong direction. All right, so in the next section, we'll be talking about text loaders. Before we talk about text loaders, make sure you have watched this Langchain crash course, so you have a basic overview of Langchain library. Assuming that you have watched this course, the next step for you will be to install Langchain by running pip install Langchain. This is the command that you run. So let me just show you. So you will run pip install Langchain to install Langchain library. And once that is installed, you can launch a Jupyter notebook, and there you can import the class. So you can say from langchain.documentLoaders import text loader. Okay, so I have imported a simple text loader. There are multiple types of loaders that Langchain offers, and we will look into them one by one. So text loader allows you to load data from a text file. Here I have a NVIDIA's news in one text file, which is called NVDA_news_1.txt. So I will just load that here and kind of show you how this thing works. So NVDA news, I think 1.txt, and I will call it loader, and then you will do loader.load, and then it returns a data object. And if you print a data object, it looks something like this. It has all the news content inside it. And if you look at it, it is actually an array. Okay, an array's 0th element is that document, which has page content as one of its elements. So let me just show you here in a separate cell. So here, if you do page content, see, it shows you the entire text content that it has. The other element that this class has is metadata. So metadata is the name of your text file. Now, if you Google, let's say, Langchain TextLoader, so let me do Langchain documentation. And if you go to the documentation here, you will find, let's see, you will find the documentation for various loader classes that you have. Now, it is sometimes hard to navigate this, and it can change based on at what time you're looking at this. But see, document loaders Python guide will give you all these loaders. So this is a text loader. The second one they have is a CSV loader. So let me talk about CSV loader real quick. So I'll just copy paste this thing here, and I have a CSV loader class here, CSV loader. Obviously I need to pass a CSV file, and luckily I have this movies.csv file which has around 9 records. You can see 9 records where you have movie title, industry, the revenue, and so on. I will provide all these files in video description below, so make sure you check it. Code, all the files, everything will be provided to you. Here I will say movies.csv, that will give you a loader, and loader.load, that will give you data. Okay, loader.load. And if you look at length of data, you will find 9 records, because in the CSV file we had 9 records. And if you look at the very first record, once again you're getting that document class. Okay, you can say type here and you will see the document class from Langchain library, and that class has 2 elements, right? Page content, which is a page content. So let's see what is inside page content. So page content is entire record. Okay, entire record in your CSV file, which has movie ID, title, and so on, separated by /n. And if you look at metadata, it has the movies.csv. Now, one may argue that this metadata, I want to have maybe movie's name or movie ID as kind of the metadata. And metadata is something that we will be using in our project. So remember in the preview we saw, when you type in any questions and it will not provide you the answer, but it will provide you a source link. So how does it reference back to the source link? The answer is, it is through this metadata, and we'll look into it. But for now, here I will say that my source column here, so my source column is, let's say, movie ID or title. Okay, so what are the columns I have? So movie ID, it has title. Maybe I can keep it title as a source column. So here, when I keep it as title, what you will see is in the metadata you get KGF2 for the first record, KGF2, right? See, for the first record, KGF2, second one, Doctor Strange, and so on. So you can view all the records. So here is one record, and then here is the metadata. See, metadata, and so on. Okay, now let's talk about the unstructured URL loader, because that is something we'll be using in our project. In our project, we will be going through some news article, let's say this particular article on HDFC Bank, and we want to load the text content from this article directly into Jupyter Notebook using some ready-made Langchain class, and that class is UnstructuredURLLoader. So this is how you import it. And by the way, you need to install a couple of libraries before that, and the way you install those libraries is by providing this particular command. Okay, In the notebook, if you run this, it will install all these libraries. Other thing is you can copy paste this into your git bash or Windows command shell and install it. Okay, it's just a usual thing, folks. You should know how to install libraries. So these are the all libraries that you need to use. And by the way, unstructured URL loader uses a library called unstructured. So if you do Python unstructured library, this is the library that it uses underneath to kind of go to that website, look into the DOM object, the HTML structure, and pull all the information. So let's create that class, and the arguments is all the URLs that you want to supply, and the two URLs that I want to supply are basically, I'll just supply two different articles here. Okay, and that will be your loader. So my loader is this, and our usual step is loader.load. You get data as a return value, and when you do length of data, it will take some time, but it will return 2 because you have 2 articles. And you look at the first article and see, again, same thing, page content. And let's see, what do we have in metadata? See, in metadata you have the source URL link. So metadata is the source URL link, and we will be using this in our news research tool. After we load our documents through loader classes in Langchain, next step is to do text splitting. And we have CharacterTextSplitter, RecursiveTextSplitter, these kind of classes. The reason we do this is because any and LLM will have a token size limit. That's why we need to reduce the big block of text into smaller chunks so that it is within this particular limit. And what may happen because of these classes that we're using in from Langchain is individual chunks that we get after we do split might not be very big, or it might not be closer to the token limit, which is 4097. Let's say the first chunk is 3000, second chunk is 1000. It would make sense if I merge these two so that it is closer to the limit and it kind of works more efficiently. So we have to perform merge step. So first you have a huge block of text, you divide things into smaller chunks, and then you can perform merge so that each individual chunks that you're getting, which is in this blue, green, orange color, they're closer to that limit, which could be 4097, 2000, depends on the LLM that you're using. We also want to do some overlapping so that when you are reading this orange paragraph, you need some context from the blue paragraph, which is one step ahead. So you see, part of this blue paragraph goes into orange also. So that is chunk overlapping. Similarly, part of this orange paragraph goes into this green chunk also. So you see this orange thing at the top, that is called overlapping the chunks. All of this can be done using some simple APIs in Langchain. So let's look at it. Here I have taken the Wikipedia article of Interstellar movie. You might have seen that science fiction movie, and we are going to perform text splitting on this one. Now when you think about text splitting, let's say I have a limit of 200 tokens that I'm using in my LLM. How do you split this text so that each chunk is of size 200? Well, the obvious thing that comes to your mind is, why don't we use simple slice operator in Python and kind of divide things that way? But when I do that, you will notice that it might cut off the words in between. See, MAT. What is MAT? Mad Demon, right? So here it is kind of cutting that off and doesn't look that great. You at least want to have a complete word. So this simple slice operator is not gonna work. Then you'll say, oh, what's a big deal? I might write a for loop, this kind of for loop, where each of the chunks, so if you look at these chunks, each of these chunks is less than 200. Okay, you can do that. But again, writing this kind of for loops is a little tedious, and it can have other issues as well. Langchain provides a very simple API so that you don't have to do all this work manually. And that API is given through various TextSplitter classes. So let's try the first simple one. So from Langchain.TextSplitter, you can import, let's say, CharacterTextSplitter. Okay. And when you have this CharacterTextSplitter class, it will take separator as an argument, separator as in through which character you want to separate things out. Here, let's say we want to separate things out with new line character, which is /n, which means each line can be one chunk or multiple of those lines, because it will do merge steps also. And my chunk size is, let's say, 200. As such, it is like 4,000 something, but just for simplicity, we are saying 200. And chunk overlap, I will keep it 0 just to keep things simple. And this is my splitter. Okay. And that splitter I can use to split the text. So I will say split text, and here is my text. And what I'm getting as a return is the chunks. And let's check the chunks length. Okay, chunks length is 9. And if you look at it, see, it's like 1, this is first chunk, second, third, and so on. And if you look at the individual chunks length, let's say for chunk in chunk, we will print the length of the chunk. You will notice that while most of the chunks are less than 200, there are some which is more than 200. See, the chunk size for these chunks is more than 200. So why did that happen? Well, let's look at some of those chunks. So the last two are kind of big. So if you look at the last two ones, you will notice that, see, this one is pretty big. In that entire chunk, there is no /n. It's like a one big or multiple sentences without /n. So obviously, it can exceed the size. Maybe you can change this /n to dot, so that, you know, after every sentence ends, it will just take that as one fragment. But what if you have a bunch of questions? So you might not have dot. Well, you can use space, but no matter what you use, you will always face one or the other issue. For some cases, CharacterTextSplitter will work, but we need something little more advanced, which can split things on multiple separators. And maybe we can have some rules that first divide things by 2/n, then 1/n, then dot, then space, things like that. And this is something that you could do using CharacterTextSplitter, which is of recursive nature, and it is called RecursiveCharacterTextSplitter. Okay, so in RecursiveCharacterTextSplitter, the arguments are kind of going to be the same, except that you can provide a list of separators. See, here you provide just one separator. Here you can provide list of separator. So I can say, okay, my first separator is /n, second one is /n, third one could be dot, or let's say space, and chunk size and chunk overlap, I'll just keep it same, and I will call this our splitter. Okay, and we will split our text. So let's say you are splitting your text, you store it in chunks, and you look at the length of the chunks. Okay, so total 13, and I will also print the size of the individual chunks here. And you can see that majority of them are now, or actually all of them are less than 200. So let's understand how it works under the hood. So what this will do internally, see, you will just make one API call, but internally what it is doing is this. So first it will try the first separator, which is this, correct? And it will split the things. So now we had a big text block. It split that into 3 chunks. See, 1, 2, 3. Okay, that is what it did. And once again, if you want to print the size, I can print it here. See, all 3 of them are more than 200 size because we are splitting using /n. So then let's think about the first chunk itself. So first chunk is this. I will just call it first split just to kind of keep things simple. So this is my first split. And if you look at the length of the first split, it is 439. When Langchain detects that, see, first it will separate things out using /n. Then it will check individual chunks. So individual chunks are 3. Okay, this is 439. So when it says that this is more than the specified size, which is 200, it will further split that using the second operator, which is /n. So here what it will do internally is it will say split this using /n, and it will get again 3 more splits. Okay, and if you look at the size of these 3 splits, let's look at the first split. So first split, if you look at it, or let me just say second split is equal to this, and in the second split, if you look at the length of the first one, it is less than 200, so it is fine. Second one is 121, it is fine. But if you look at the third one, it is 210, so it is definitely more than 200. So what it will do is it will then go look at the third separator, which is space, and then it will separate things out. And once it separates things out, then it will again merge. We looked at the merge step, if you remember from here. See, it will also do merging because each individual chunk size might be too small, so it will just kind of merge everything. So obviously when you split things apart using space, so let's do that. So when I split things apart using space, obviously each chunk will be very less, right? This chunk is only 3 character, this is 2 character, 1 character. We can't have chunk which is that small. So it will then merge those things as I have shown you in the slide. It will merge things such that it is kind of optimized. So what it will do is this. See, let me just print for chunk in second split, print the length of the chunk. First two, it will keep it as it is. The third one, it will divide. So what is our size? 200. So it will say, it will create one chunk using size 200, the other one using 10, roughly. It could be plus or minus b because you need to keep your word intact. You can't break the word apart. So that is the reason when we are using this API, see, you got 199 and 10. See, 210. I mean, there is a space character, so one character is here and there, but you see 105, 120, so 106, 121. Okay, so those two are same. And then there was 199 and 10, so it split this 210 into 2, 199 and 10, so it is like 209 and one space character, so total 210. So that is how it is doing the splitting. I hope you got some understanding of recursive text splitter. This is something that we'll be using in our news research tool. Now that you have some understanding of text splitter, let's look into the next step, which is vector databases. Now for vector databases, there are a lot of options, Pinecone, Milvus, Chroma, but we are not going to use them in our project. We will use something called FAISS, which is a kind of like a lightweight in-memory vector database type of thing. FAISS stands for Facebook AI Similarity Search. It is actually a library that allows you to do faster search into set of vectors that you have, but it can be also used as a vector database if your project is smaller and if your requirements are kind of lightweight requirements. Okay, so you can read about FAISS, but I will give you a very quick understanding. So what will happen is, once you have a set of chunks that you have created using recursive text splitter for our project, we will convert those into embeddings. See, embedding conversion is a must step. We can use either OpenAI embedding, Hugging Face embeddings, Word2Vec. There are so many embeddings out there in the world. Based on a problem statement, we can use any of them. And then we will store them into a vector database. So if we are using Pinecone or Milvus, we would have stored these into that proper vector databases. But for our project, we are just going to store them into FAISS Index. This is like an in-memory structure which can do a faster search on your vectors. So let's say if you have an input question called what is the price of H100 GPU, we will again first convert that into a vector using the same embedding technique. And then we will give it to FAISS Index. And what FAISS Index will do is, let's say these vectors that we have created out of these chunks are, let's say I have 1 million vector. FAISS will efficiently perform a search for a given vector. And it will tell you out of those 1 million, how many of those vectors are similar. Okay, and this I have explained in detail in this particular video, which I'm going to provide a link in a video description. So please watch it if you haven't seen that. But let me just quickly show you how FAISS works by using some simple code. So you have to first install these two libraries. Okay, and once these libraries are installed, I'm going to import pandas and I will just increase the pandas data frame column width. I'll explain why I'm doing that later on. But I'm loading a CSV file which has like 8 records, so different 8 text and their category. They are either health, fashion, these type of categories. So I'm loading that into a data frame here, and my data frame shape looks something like this, and my data frame looks something like this. Now I will convert these text, okay, these 8 sentences into vectors. And the way I'm going to do it is using the sentence transformer library. So I will say from sentence transformer import sentence transformer. Okay, and for this sentence transformer, I'm going to use a model or a transformer entity called this all MPNet. And if you want to read more about this, you can just say Hugging Face sentence transformer. You can do reading and you can kind of figure out how it works. But in simple language, all they're doing is converting this text into a vector. So how does it do that? So I will just say encoder is this, and then encoder dot encode. Okay, and that encode expects an array of text. An array of text is df.text. See, df.text, when you give it, it gives you that entire column, and that you can store in the vectors. And let me just print the vector shape. It might take some time, by the way. If you're running for the first time, just have some patience. You can see that there are total 8 vectors. If you see this, it's like a 2-dimensional array. Okay, so first one is this, second one is this, third one is this, and so on. So meditation and yoga can improve mental health. The vector corresponding to that is this one, and you see dot dot dot. So the total size of one vector is 768, which I'm going to store it in a variable. So see, so vectors, if you do vector dot shape and 1, so this is the size of each vector, and we have total such 8 vectors. I will store this into a parameter called dimension, because that dimension I'm going to use later on. And then I will import the FAISS library. Okay, so once FAISS is imported, I will call index flat L2. So this is the index that uses a Euclidean distance or L2 distance. Okay, so that's the index that we are using. Once again, if you want to know more detail, you can go to either FAISS.ai or go to their GitHub page. You can do more reading, but as such, it is very simple. It is just creating, similar to a database index, it is just creating an index that allows you to do faster search later on. Okay, so here I can supply dim actually, and that will be my index. So I'm creating an index of size 768 here. And when you print that index, you'll see nothing. It just created some empty index. Now in that empty index, I can add some vectors, correct? So when I added it, now my vector is kind of ready. So going back to that picture again, we have total 8 vectors, right? Total 8 vectors, and the size of each vector, the size of this particular array is 768. We are just adding that into FAISS Index. Now FAISS Index will internally construct some kind of data structure. What that data structure is, That is out of the scope of this video, but some data structure that allows you to do fast similarity search. So for a given vector, we can find, okay, out of these 8 vectors, which 2 vectors or which 3 vectors are similar. Okay, so here now, once I have index, I can do index.search, and here I want to supply search vector. But what is the search vector? Well, we don't have search vector ready, so I will give some input search query, and the search query is, let's say I want to buy a polo t-shirt. Okay, and that search query we have to, of course, encoder.encode. If you look at that picture, we need to kind of convert this into a vector. So that is what I'm doing here when I say encode my search query, and I get the vector back. If you look at the vector shape, see, it's a simple array 768, but this search vector expects 2-dimensional array. So I'm going to use NumPy and convert this vector into 2-dimensional array. So it's simple, folks. What I did is something similar to, you know, I put, let's say, vector into an empty array outside. So it was 1-dimensional array 768, now it become 2-dimensional. And if you print that, see, vector was simple 1-dimensional array, but if you look at this as vec, now it is same vector, but see, there is one outer array outside that, and the reason is this particular function expects that format. Okay, okay, some argument is missing. How many similar vectors do you want? This is like kth nearest neighbor. So let's say I want 2 similar vectors, and it gives me these 2 vectors. Okay, so it returns a tuple, and the first one is the distances, the second one is the index in our original data frame. So in our original data frame, locate the rows which has index 3 and 2. Okay, so which one is 3 and 2? So 3 and 2 both are articles related to fashion, and you can see that I want to buy a polo t-shirt is kind of similar to fashion. Okay, so that's what it did. I can store them in distances, and I can store them in tuple. And if you look at I, right, 3 and 2, you can locate that using df.loc. So if you do df.location and do 3 and 2, it will give you those articles. And if you want to be kind of like in a programmatic way, you can do it similar thing. So I of 0 is 3 and 2 only. Okay, so that's what it is giving you. Now, one thing you might have noticed is in this text, okay, let me print the text here, search query. So in this text, I want to buy polo t-shirt. See, the exact word is not present here. See, so this is not like a keyword search. This is a semantic search, which means it is capturing the context or the meaning of this sentence and giving you the similar sentence here. If you look at our entire data frame, see, it has meditation and yoga and all that, but it gave you only fashion related articles. You can change a sentence. So let me say that an apple a day keeps the doctor away. Okay, and I will go here and I will say run all the cells below this particular cells. Okay, I think there is some problem. Okay, let me run all the cells here. You notice that when I say an apple a day keeps doctor away, the search results were related to health. Once again, you will see that in the similar vectors, which are these two, the exact words are not matching. See, an apple day keeps the doctor away. It is not present in any of these sentences. But if as a human, you have to think which are the 2 similar sentences for an apple a doctor keeps doctor away out of all these 8, you would probably give these 2, because we are talking about health here, and it gave me the health related articles. Okay, you can try something else, which is looking for a place. So let's say looking for a place to visit holidays. Okay, and go to cell, run all, and you notice once again it gave you 2 articles which are related to travel. So I'm going to provide all these individual notebooks, by the way, in the video description below. So just check it, just think about it, and you will get an idea. So This was just a quick demo of FAISS library. This is something that we will be using in our news research tool project. Let us now discuss the RetrievalQAWithSourcesChain. Once you have stored all your vectors in a vector database, the next component will be asking a question and retrieving all the relevant chunks. Let's say my relevant chunk is chunk number 2 and chunk number 4. Using these chunks, I will form an LLM prompt. The prompt will be something like, I have H100 GPU, what is the price of it? Give me the answer based on the below text, which is chunk 2 and chunk 4. And then LLM will give you the answer. The benefit of this is you can tackle the problem of the token limit and also save some bill on your OpenAI calls. So now when you think about combining this chunk, see here what we did is whatever chunk you get, you put all of them in one single prompt. Now, as a result, here I got chunk number 2 and 4, but actually I might get more chunks. Let's say I got 4 chunks and combined size of these chunks is more than the LLM token limit. So then that is the drawback of this method. This method is called, by the way, stuff method. So you're getting all the similar looking chunks from your vector database. Then you're forming a prompt. And when you give all these chunks together, it may cross that LLM limit, token limit. So that is a drawback of this method. If you know that chunks will not cross LLM token limit, then it's fine. The stuff method will still work. It is the simplest of all. But the better method, especially when the combined chunk size is bigger, is MapReduce. In MapReduce method, what we do is we make individual LLM call per chunk. So let's say I have these 4 similar chunks. So for my question, let's say what is my H100 GPU price? Give me the answer based on chunk 1. Then again, I'll ask a question. What is the price of H100 GPU size? Give me the answer based on chunk 2, chunk 3, chunk 4. So you are asking 4 different questions, and each time you pass different context, which is chunk 1, 2, 3, and 4. Obviously, you get 4 answers. Here there is a typo, by the way. This is FC1, FC2, FC3, and 4, and so on. So this is like a filtered chunk or an individual answer. And then you make a 5th call and you combine all these answers together. And you say to your LLM that out of all these 4 answers, just give me the best answer, or just combine all these answers together and give me the final answer. This way, you will tackle that token size limit. But the drawback here is you are making 5 LLM calls. See, 1, 2, 3, 4, and 5. In the previous method, you made just 1 call. So that is always a drawback. So now let's do some coding and try to understand this thing in a little deeper fashion. I have imported all these necessary libraries. You need to give your OpenAPI key here. Okay. If you create a free account, they give you like $5 free credit. So you can use that, and after this account is created, you get that key. Okay, we have covered all of that in our Langchain crash course. So here I will create an LLM object, and then I will use UnstructuredURLLoader. This is something, folks, we have already looked into it, so I will not go in the detail here. I'm just loading 2 different articles. So first article is on Tesla. Okay, Wall Street raises Tesla, whatever. And the second article is on Tata Motors, which is India-based automotive company. And here we are loading both of these articles into our data loader. And then we are using the same RecursiveTextSplitter, which we have looked into before, and creating these individual chunks. So we created total 41 individual chunks. I mean, you can check the individual chunks here. See, this is the page content. Okay, 0, 1, 2, 3, 4, whatever. You can check it out, right? Like 9. And then once that is done, you will create OpenAPI embedding. So how do you do that? Well, see, we created this particular class here. So I will say embeddings is equal to OpenAPI embeddings, and then you will use the FAISS class that we imported here and call a method called from documents.
Now see, from documents method in FAISS will accept the documents or the chunks that you created here, and then it will take another parameter which will be your embedding. So here I'm using OpenAI embedding, so I'm giving that. You can use Hugging Face or any other embedding too. And the resulting index will be this vector index which we have. And once you have that vector index, so I'm not running this code by the way, because I already ran this code and I have saved this vector index into a file. Okay, and the way I saved it is I can use this code. See, you have a vector index, and then vector index you can write it to a file called vector index pickle file. So previously, before shooting this tutorial, I already ran this code. I saved vector index into a file, and let me show you that file on my disk. See, vector index.pickle file. So this is sort of like a vector database. It is a vector database which I have saved as a pickle file on my disk, and now I can load that pickle file by running this code. See, now I can run this code and my vector index is loaded into a memory. So this vector index now have knowledge of both of these articles. Now let's create a RetrievalQAWithSourcesChain class object. The first argument that it expects is LLM. So wherever we created our LLM, which is here, you know what, just to, okay, I'll just put that in here. And the another argument is retriever. So retriever is basically how you're planning to retrieve that vector database. So vector database you can give as an argument here, and you can just say as retriever. Okay, this is just a syntax that we're using, and this thing we are going to call it a chain. Okay, here I need to say from LLM, and you will see that it has created this chain, and in the chain you will see interesting prompt which might get you very excited, which is this. See, use the following portion of long document to see if any text is relevant to the answer of this question. This is the thing we have discussed before. Now we are going to ask some sample question. So my sample question is, what is the price of Tiago ICNG? And if you look at the article, the Tiago ICNG price is between this and this. So you would want this particular answer from our code. Okay, so that is my expectation. I will enable the debugging in Langchain so that I can see what's going underneath, and then you will say chain. In the chain, the question that you want to ask is this, and this is the argument that you give. Okay, so now let's run this code and see what happens. So this will kind of show you some internal debugging. So when I said what is the price of Tiago ICNG, first it retrieved the similar looking chunks from my vector database. So there are total 4 chunks, 1, 2, 3, and 4. Okay, and the question is same for all of these. So see, the chunk is the company also said it introduced Tiago. See, my actual answer is read in first chunk itself, but it will still retrieve 4 similar looking, most similar looking chunks. Now see, this is also similar looking, but my answer is not there exactly. This is also similar looking, and this is also similar looking. Okay, all this code is available in the GitHub, by the way. You can run it and you can just go through it yourself. So that is step number 1, which is chunk 1. And then you combine a question and you ask 4 questions, individual questions to your LLM. So all these questions will go to the LLM. So my first prompt is use the following portion of a long document to see if any of the text is relevant to the answer of these questions. Right? Return any relevant text verbatim. And this is the paragraph that you give. Okay, similarly, this is the second question, this is the third, and this is the 4th question. So these are the 4th questions. So you passed all those 4 questions to LLM. So there are 4 LLM calls. As a result, you will get 4 answers, correct? So let's see the 4 answers now.
So the first answer is this, the Tiago ICNG price. So you know this is the final answer, but still it will generate 4 answers. So this is the first answer, this is the second answer. This answer doesn't look good, but it will still give you some answer. This is the third answer, and this is the fourth answer. Okay, so FC1, FC2, 3, 4. These are the 4 answers that it gave. Now you will combine those 4 answers in a summary chunk and give one more call to your LLM. So where is that question? See, these are the four answers. Okay, 1, 2, 3, 4. Now here is the combined summary. What is the price of ICNG? So the summary is content. See, 4 answers are combined. So given the exact prompt is given the following whatever summaries, give me the final answer. Okay, and then in the end it will give you a final answer, and the final answer is the Tiago ICNG price is between this and this is the source reference. Okay, so once again it is using this map and reduce method. I have given this notebook with a lot of comments, so maybe you can read it and get an idea. But overall, now what happened is we looked at all the individual components. We started with TextLoader, Splitter, FAISS. We talked about Retrieval just now. Now we are going to combine all these pieces together and build our final project. Our final project is not going to take much time because all the individual pieces are ready. We have also understood the fundamentals behind the scenes. See, learning only API is not important. You need to understand the fundamentals, how it works underneath. Then only you can become a great data scientist or NLP engineer. So far, we have cleared all our fundamentals. Our individual pieces are ready. We need to just assemble them, and it's not gonna take much time. I'm super excited to move on to the next section now. And this is the argument that you give, okay? So now let's run this code and see what happens. Now we are going to use all the components that we have built so far. We will assemble them and build our entire project. I have this directory where I will be keeping my project. In the notebooks folder, you will see all the individual notebooks, and here outside I will do main project coding. Right now you're seeing 2 files, requirement.txt and .env file. If you look at requirement.txt, it has all the libraries which we are using. So you can run pip install -r requirement.txt to install all the libraries. In the .env file, I have OpenAPI key. So you will put your own key here, which you have got by getting that $5 free credit on OpenAI, or if you have paid account, just use that. Now let me create a main.py file here. So I will say main.py, and here I'm going to import all the necessary libraries. So since the list is pretty long, I'm just going to copy paste it from somewhere. And the very first thing I will do is load that OpenAPI key. Now so far we were using os.environment variable, but that's a little clumsy way of doing it. There is a better way, which is using the .env Python module. So if you look at this particular Python module, you have to install it first of all, and then you can just use these 2 lines, and I'll tell you what they do actually. So here it will take all the environments variables from .env file and it will load them into the environment. Okay, so if you look at let's say env file, .env file is this. So it will set domain environment variable as this, root URL as this, and so on. Okay, so it's just one call, and within one call we have loaded our API key, and the API key is not visible in the code. So it's kind of like a cleaner way. It's standard practice that people are using nowadays for loading this. Now let me just write some basic UI. So I will say st.title. Okay, our title of the application is news research tool. So that's what I'll say here, and then I will create the sidebar. So if I were to show you the UI of the our tool, it will have on the left hand side, it will have this kind of 3 URLs, URL1, so this is URL1, this is URL2, this is URL3. I will have process button below it, and the title that I'm putting is here. It will be visible here, and here I will have on the right hand side the actual question, and below that there will be an answer. Okay, so in the sidebar, I'm going to say sidebar title, news article URLs. Let's say that's my sidebar title, and I will have 3 URLs. So I will say for I in range, let's say 3, okay, and st dot sidebar dot text input. So I will take the URL from text input, and I will use a format string here. I will say URL I plus 1 because it starts with 0. So I'll say URL 1, URL 2, and URL 3. Okay, and below that there will be a button. So the button will be called process URL maybe. Okay, and when you click that button, that value I will get in process URL clicked. And when I say process URL clicked here, when I press that button, the flow will go here. Okay, let's just run whatever we have so far and see what happens. Okay, so the way to run this is Streamlit run main.py. When you run that, it will show you this kind of UI. See, 3 URLs. There's a news research tool here. We'll add the question box, but here you can add those URLs. And when you hit this button, process URL button, actually the flow will go to this if condition. Okay, so let's write some code inside this if condition. So here we will use the unstructured URL loaders, and we will get all the URLs. Now here you need the URLs, right? So where are my URLs? So let's say I create this URL variable, and those URL you can build that array here. So whenever you enter that URL, it will come to this array, and that array is passed here. Okay, and that is called loader, and you do loader.load. Okay, this should be very apparent to you. So this first step is loading data. After you load the data, you all know next step is splitting the data, and for that you will use RecursiveCharacterTextSplitter, which has 2 arguments, I guess, separators and chunk size. I'm not worrying about chunk overlap that much, although you can play with it. So this is my text splitter, and I will say from text splitter split my documents, and my documents will go here, and I will get the individual chunks. Okay, and those chunks I will then do embedding. I'm going a little fast because we have already covered all these things before. Create embeddings, and okay, let's say create embeddings. Okay, so these are the embeddings I have, and then you will say FAISS from documents, and the first argument is documents and the second argument is embeddings. Okay, and save it to FAISS index, and we'll call this particular variable, let's say this. Okay, and then we are going to save this in-memory FAISS index that we have on disk. So we'll save it in a pickle format, and here is how you save it. The file path is going to be, you can give any file name. Okay, so I'm just going to give, let's say, FAISS store OpenAI pickle. Okay, so that is stored here, and just to show the progress when we are processing the URL. So let me just show you the UI here. When you enter a bunch of URL here, process URL here, like below this news research tool here, I want to show a progress bar. So progress bar will say, okay, loading the data, splitting the data, things like that. And for that, we have to use a main placeholder. So I will say main underscore placeholder is equal to st.empty. So this way you are creating an empty kind of like UI element. And when you are loading the data, you can say dot text, and you are saying, okay, data loading started. Okay, so I will just again copy paste here, and I will put this kind of progress bar before, I think, split document, and also here. All right, so far I think my code looks good. I can rerun this and see how it goes. So I'm gonna rerun. So you can click on rerun or just place R button. So my code is rerun now, and I'm going to give these 3 articles here. So this is my first article, then this one is my second article. So first, second, and the third one is this. All 3 are articles related to Tata Motors, and see, it will say data loading started. So now it's loading, going to these 3 URLs using UnstructuredURLLoader, loading the data. Then it is splitting them into 1000 token chunks. Then it is building embeddings using OpenAI API calls, and then it is using FAISS to kind of build an index and save it to a disk. So when you look at the folder that we have, you will find this file, FAISS store OpenAI pickle. This is like our vector database. So now our vector database is ready. So next step, we will enter a question box here. Okay, so let's do that coding now. I'm going to say main placeholder dot text input, and the text input will have question, and whatever query you are getting, that question, you will say if query. So when you type in a question, hit enter, it will come here. Now what should be the first thing that you'll be doing here? Well, you will be loading the vector database. So you'll say, okay, if the file exists, there could be a reason where this particular file, doesn't exist. So you want to make sure you're doing that check. If the file exists, then you need to read that file. So you will say with open file path, read, it's a binary file, as f, and pickle.load. So you load that file and you call it vector store. Okay, we are using the Python's like pickle module. You can see here we have imported that, and then we are creating the retrieval QA chain. Okay, so vector store is here. This QA chain expects LLM as an input, so I don't think we have created LLM. So let me just copy paste it here. I have the code ready here so that I can save time on the recording. So I have created LLM object now. My chain looks good, and then in chain you will say what is the format. So you supply a question here. Okay, this particular argument you will supply as true, and then you will get your result. Now result will be a dictionary which will have 2 elements. Okay, so result will have, it will look something like this. So it will have answer, and it will also have whatever is the answer. So it will have whatever is the answer, and it will also have sources which will contain the URLs or whatever. It can be an array. So result answer contains answer. We need to display that, right? So st dot or main placeholder dot, you know what, I will just use st dot header here and say here is my answer, and then st dot subheader, and that subheader will have result answer. Okay, so let's try this much so far. So I'm going to bring that UI here, click on rerun, and it just reran. And I will ask now, what is the price of Tiago ICNG? Okay, so this is the question based on those 3 articles. If you look at that article here, I think it is here, see, ICNG's price is 6.55 to 8.1, and see, it is giving the answer properly. I want to also see the source, like from which URL it retrieved the article. So we can do that real quick here. Just to save time on recording, I'm not going to go too much in details because this is very minor. So you are basically going to result and get the sources element from the dictionary, because in that dictionary this might not be present. Okay, this may be present, this might not be present. That's why I'm calling get argument. And if it is present, then you are creating another subheader and providing sources list. Now why list? Because sometimes answer may come from multiple URLs. So you need to handle that scenario. So let's bring this code here. Now rerun this and ask the question again. See, Tiago CNG's price is this, and here is the URL. So if you look at this URL, it will have the answers. Correct this. Now you can ask a summarization question as well. For example, I have this article, KR Choxis, and I want to just summarize this article. This is their recommendation on this talk. So I will say, can you please summarize this article? Okay. And by the way, this is like bold. So let me just change this thing. I'm just going to call it right because that way it is not bold. Okay. So here you see it already summarized the article and it also gave the source for that. But this is like little bigger font, so I'm just changing it to smaller font. But overall, folks, this tool is ready. Now it's going to be very useful to my equity research analyst, my Peter Pandey, who is investing on Rockybuy's behalf, because now you don't have to read so many articles. Whatever question you have, you can ask it to this news research tool. It will not only give you the answer, but it gives you the sources references. This is very important, folks. And by the way, with LLM boom, many clients are building this kind of tool. How do I know it? Well, my own company, Inatlic Technologies, we have some US-based clients for whom we are building these LLM projects. And this is a real life use case that I'm showing you. So this is not like a toy project. It is based on a real things which are happening in the industry. Document summarization, building chatbot similar to ChatGPT on custom data. So this is sort of like we build a chatbot which can answer your questions on custom data, which is these 3 URLs. So we just built the basic proof of concept and it is already working. Code, everything is given in the video description below. So please try it out. Long term, we have discussed this, like long term, when you're building this project in the industry, you will build 2 components. One is data ingestion system, where you will write some kind of web scraper that goes through all these websites and it retrieves all those articles. Now for web scraping, you can use native Python or Bright Data. Even UnstructuredURLLoader will work, but it might start not working at some point because websites will detect the scrolling activity and they might block you. That is the reason why people use tools like Bright Data, which is a proxy network based tool. Then you will create embeddings. It could be OpenAI, Hugging Face, and store it in a vector database. So if I'm doing this in the industry, like a big project, I will not use FAISS. I will use vector database. I can still use FAISS as a library, but otherwise I'll use a vector database. And once you have data in the vector database, you can build UI in React or whatever tool, and then call that vector database to retrieve the similar looking chunks and post the answer back to chatbot.
Data, data, data. Data lights me. I can't avoid it.
Hope you liked this video. If you did, please give it a thumbs up, folks. See, we have done a lot of work. This is like a full end-to-end real industry project. This is not a toy project. And I really appreciate if you can share this with people, spread the word about this awesome work that we have done. It is available, all the code, everything is available to you at no cost. So I hope you understand this, and this project is going to look pretty good on your data science or NLP resume. Okay, so please make sure you implement the entire project as per the guidelines. Share this project with people, and if you have any question, there is a comment box below. Thank you very much for watching.